So going to have a look here at 2018 11B. Now I think the problem was with the second part, but I'll just quickly fly through the first. Arrhenius' definition of a base, a substance that disassociates in water to produce OH minus ions. Why is NH3 considered to be a base according to the Bronsted and Lowry theory? A base is a proton acceptor. Okay, so NH3 is a proton acceptor. Then you're asked to calculate the pH value of a 0.5 molar solution, 0 molar solution of HCl. So firstly here HCl splits into H plus Cl minus. So ratio there is 1:1. So if I have 0.50 moles of HCl, I have the same number of moles of H plus. So then pH is minus log to the base 10 of my H plus ion concentration. That's equal to minus log to the base 10 of 0.50, and that's going to give me an answer there of minus log of 0.50, 0.3. Okay, so that's my answer to part I. And then my answer to part I then, I'm told I have a 0.05 molar of ethanoic acid with Ka equal to 1.8 by 10 to the minus 5. Okay, so in order to do this, I am going to firstly work out my H plus ion concentration. So H plus is equal to the square root of Ma by Ka. Ma in the question is 0.50 multiplied by Ka 1 by 10 to the minus 5. So that's going to give me the square root of 0.5 by 1.8 by 10 to the minus 5, and that gives me an answer. So square root of 0.5 by 1.8 by 10 to the minus 5 gives me 0.003. So then my pH equals minus log to my base 10 of my H plus ion concentration minus log to the base 10 of 0.003, and that gives me an answer there of 2.5228, so 2 is my answer for that. Okay, so that is both of your calculations there. Then you're asked for part, the last part. So you're told that I have the pH curve was obtained when 100 centimeters cubed of 0.50 molar sodium hydroxide solution were gradually added to 50 centimeters cubed of one of the two acid solutions mentioned above. And you're asked which of the two acidic solutions was neutralized. So I have one of two options, okay? The only options I have is ethanoic acid and hydrochloric acid, okay? And just if we look at the answer here, so if I look at my value, it's at 2.52. So straight away, if I look at what my calculation was here, my starting pH is my pH for ethanoic acid. So which of the two solutions was it? It must have been ethanoic acid. Okay, and then you're asked to give two pieces of evidence. The first piece I've just explained, okay? So my starting pH was 2.52, which I've worked out to be the answer from part II, okay? The next one here is that if I look at where my pH rise is, so my pH rise here is between 7 and 11, okay? So that's where the pH rises, my steep vertical part of the curve, okay? So here I have my vertical rise is above pH 7. Okay, so because of that, again, I must be titrating a weak base versus, a weak acid versus a strong base. And the next thing then is that what is the essential property of an indicator used to detect the endpoint in a titration between this acid? The biggest reason why any indicator works is because the colour change works within that range. So you'll have a colour change that coincides with the vertical section or steep section of the graph. And that is the answer to that question.